All right, we're going to roll into the lesson, then we'll go over homework questions because I'm sure we have at least a couple homework questions. All right, we're going over special types of... Sangha, do you need something?
Yeah.
Oh, thank you.
Oh. All right, we're going over special angles. It's not that intense of a lesson, but it is very important that you recognize these things because they will keep reoccurring over and over and over and over and will definitely be prevalent in the test next Friday. So the first thing we're going to talk about are complementary angles. The big thing to think of when you hear complementary angles is 90 degrees. Complementary angles are those angles that add together to equal 90 degrees. Okay. Do you need it right now? Oh, when I check homework, you can go get it.
Okay.
That way you're not. Yeah.
What was the name that angle 180?
180 is going to be a straight angle.
Just straight angle.
Straight angle. And then we're going to add something to kind of 182. Yeah.
Okay.
A straight angle is just a straight line. Straight angle. Complement is 90 degrees. Did you have a question? Oh, okay. It was just, I saw your hand in the peripheral. I think I saw two hands. Is that okay if you wait to get it then?
Yeah.
Okay. So we had a straight angle, which is 180. Complement are two angles that add up to 90 degrees, just two angles. They can either be adjacent or not adjacent. So if I write an angle over here that's 40 degrees, and then I write an angle over here that's 50 degrees, they're complements of each other because when added together they equal 90. Doesn't matter where they are. They can be adjacent, but they don't have to be. If they add to 90, they're complements. Supplementary, on the other hand, are those that add up to 180 degrees. Just like complements, they could be adjacent, which they're going to have a special name if they're adjacent. I point down here because that's actually on your sheet. I'm not actually pointing down on my board. Or they can be non-adjacent. Like this is 50, this is 130. Angle A and B are supplements because they add to 180. The big thing is adding to 180. This is kind of the formula. So if this is 130 degrees, the other angle is 180 minus 130, so it's 50 degrees. It's kind of a quick formula if you don't want to do math as much. All right, find the complement and supplement of each angle. So we need to find the complement and supplement of each of these. If my measure is 10 degrees, what is the measure of that complementary angle that makes it a complement, I guess? Yeah. It's going to be 80 degrees. Because 80 plus 10 equals 90 degrees. Can someone tell me what the supplement of this is then? Since you were the brave one to come up with the first one. Yeah. 170 degrees. Perfect. All right, I need the complement 15 degrees. Perfect. And who wants to give me the supplement? Careful. Careful. Yeah. 105. I say careful because it's really easy to write down 115. For some reason, it just is. Because you had 15 above, 115. But it's 105. Makes it equal 80. All right. Yeah, sorry. Oh, you got the next one? Oh, I didn't even write anything down yet. Easy. Okay. What do you got for the next one?
90 minus y.
It is 90 minus y. Awesome. So I don't care how you write it. Technically, the 100% correct way to do it is to do that. I usually just put 90 minus y because we're not actually writing a full number out. So you could write 90 degrees minus y degrees, or you could write the whole thing. It's kind of murky, so I just leave 90 minus y. I'm not really worried about the degree symbol on that. All right. We hit that brave soul that got the 90 minus y. What's the supplement then? What is the supplement then? 180 minus y. Cool? Got it? Complement, supplement, know those words, know what they mean. So when you hear complement, think 90. When you hear supplement, think 180. Probably not the best way to do it, but I always think of like supplementary, like if you have a big supple apple, it's a big apple, so it's a big angle. Supple means bigger. All right, that's why my supplementary is 180. All right, linear pair are two angles that are two things. They are adjacent. And I changed the wording on this a bit, so get rid of that A, because it doesn't make sense there. I changed the words. And form supplementary angles. They form supplementary angles. And that is my shortcut for angles, rather than having to write angles. Because we're going to write angles a lot, especially when we get to triangles. We're going to write angles a lot, so it's nice just to be able to write that with an S. It speeds things up. Supplementary angles equal 180. So a linear pair has to meet two requirements. They have to be adjacent, and they have to be supplementary, which means they need to be a straight. They need to be able to form that straight angle that Songhua was asking about in just a second. So these are going to be examples of a linear pair. Angle 1, angle 2, because they are adjacent, and when added together, they equal 180 degrees. So once again, adjacent and angle, I should probably put measure. Measure of angle 1 plus measure of angle 2 equals 180 degrees. Do supplementary angles need to be adjacent? Do just supplementary angles need to be adjacent? Just shake your head up or down, no? No, they do not. Do linear pairs have to be adjacent? Yes, so I think of linear pairs as being the step up from supplementary. You have supplementary angles, and then if they're adjacent, you can also call them linear pairs. I'll be honest with you, I don't use the term linear pair very often. I more or less say they form a straight angle. Straight angle is kind of the bigger term there, yeah.
So the linear pair is like, is it the angle, or I'm just...
It'd be the angles. It'd be the angle 1 and 2 are linear pairs.
That make 180.
So you'd name both of them. If I say name the linear pair, you'd name angle 1 and angle 2. But like I said, we don't spend a bunch of time talking about that. I more or less care that they equal 180 degrees. That is really your takeaway. If I say linear pairs, think 180 degrees. All right, vertical angles. Those are just angles that are across from each other. How much did I leave each other? When two lines intersect, I'm going to save a little space down here, maybe just like a little box here, because we're going to put a non-example that I see people making mistakes on. So leave a little space. I'll try to space stuff correctly for how I'm writing it. All right, so we have vertical angles. We're just looking for angles that are across from each other. So examples here. So we have two lines. One line, two line intersecting. They're going to be vertical angles. So I'm looking at this AB pair. And I'm also looking at C and D. So that's going to tell me angle A and angle B are vertical angles, which I'll just put as vert. And I'll put my little angle symbol. And then angle C and D are also vertical angles. Yeah.
So you have to put an at the before angle A, like you put an angle A or something.
We're not talking about the measure. We will in just a second, but this isn't specifically talking about the measure. I'm just saying that those two angles are across from each other. Measure doesn't matter right now. I'm just saying those two angles are across from each other. So if I'm just talking about the angle, I don't put M in it. M is only when I'm going to actually talk about like 40 degrees, 50 degrees, or that their measures are the same or something. Okay? And generally we're going to use M when we're going to use numbers. So like M of angle A equals 45 degrees. All right, I'm going to put a non-example that I see people making mistakes on all the time. So this is going to be a non-example. We'll talk about why it is. So these will look kind of like vertical angles, but they are not vertical angles. 1 and 2 are not vertical angles. Does anyone want to venture a guess why those aren't vertical angles based upon the definition? It's kind of hard to see. Yeah. Because it's not two lines intersecting. In fact, when you saw me making this, I had to make 1, 2, 3 lines. Yeah.
So if those two lines were to go through the middle line, then you could consider them.
So if you picture these lines gone and these went
Yes.
straight through, then it would be vertical angles.
Okay.
Yep. So
Now they're raised.
yep.
Okay.
So it has to be exactly 2 lines crossing. When I formed this, you saw me like struggle to make 3 different lines. Are we all okay with that not being vertical angles? Yes.
Wait, if the lines went through, wouldn't it be one and then the angle like under the two?
Yes. Yes. So if so, I think you're picturing it a little different than she was describing. I think you're picturing that. That's what you're picturing, right?
Yeah.
So that would be this whole thing would be vertical to that whole
Oh.
thing. Yeah.
But when it would, those 1 and 2 would still be, in that case, they would still be,
Not vertical angles.
because you don't know how. So when would they be vertical?
When would they? Let me put purple on top of this. Purple signifies kind of our vertical angles.
So if the middle line was not there,
If the middle line was not there, then 1 and 2 would be
Yeah.
vertical angles. Yeah. So if you just look at the purple thing, this angle and this angle are vertical angles.
so in no case within that, where there's 3 lines, there's no case where the 1 and the 2 could possibly be
Correct.
congruent.
They could be congruent, but they're not vertical angles.
Oh, yeah.
Because I could say this is 30 degrees and this is 30 degrees. They're congruent, but they're still not vertical angles. Vertical angles need that crisscross.
Oh, yeah, I see it now.
They need that.
It could be like
So this whole thing would be a vertical angle for this whole thing, straight across.
Yeah.
Yeah. EJ.
Oh, okay, never mind. I was reading something.
Oh, okay. Yeah.
It does have to be concurrent, like it does have to be same angle as number 1 and number 2 has.
They will be the same angle.
Like if I put it like something like that,
Then it's a vertical angle.
here, like only this one is vertical.
Yep.
Not
Yep.
this one.
Though those are also vertical. Anything that's across from each other.
Got it.
Yep. Yeah.
So if you send a 1 and 2, they're not vertical, but if you erase the middle line, then it's vertical?
If I raise the middle line, were those the lines I was drawing before?
Yeah.
Or do you want a different line? So you're talking about the purple lines I just drew?
Yeah. So right now it's not vertical.
1 and 2 are still not vertical, because let's look at what 1 and 2 are. 2 is this angle,
Mm-hmm.
and 1 is this angle.
Oh.
The only way that they're vertical is if 1 and 2 were actually talking about the full. So if I would say angle 1 is actually this full angle, and this 2 is that full angle, then they would be vertical angles.
Okay.
Do you see those?
Yeah.
Yeah. So what you're trying to do when you're looking for vertical angles is kind of look for 2 lines that cross and let everything else kind of disappear. So when I'm looking for vertical angles, you need to let those red lines kind of fade to the background and look at those just the 2 lines that are crossing. Bless you. All right, and real quick, theorem, because we're going to talk about a theorem. Yesterday we talked about postulates. Today we'll talk about theorems. A theorem is a statement that can be proved. And in fact, we will prove most of the theorems that we're going to talk about. So I just kind of here, I'm going to put both things. Postulate equals basically no proof. We're not going to prove it. And a theorem we prove. So we're going to need a proof. Postulate, no proof. Theorem, proof. Theorems are these big bad guys on the block. Postulates are the little guys that build up the theorem. Vertical angle theorem. I want you to look at your pink sheets, because anytime I talk about a theorem, a postulate, or anything, your goal is to look at your sheet. First, ask yourself, is this theorem on there? So you're going to go to your very, I think yours is not on your very back side, but it's on your last page on the front. It says theorems. If a theorem I describe is not on there, you need to write it down. That's why you have a whole backside in case you want to. This one is on there. Let's look through those and someone tell me which theorem is our vertical angle theorem. So once again, theorem 4, draw a picture on it. You could almost, where am I? I went too far. You could almost just draw that picture. You could even circle your vertical angles. You could do that. You could circle what a vertical angle is. You can put the not a vertical angle if you want to. It might be a little confusing to have too much stuff on there, but I would definitely, on theorem 4, have vertical angles highlighted or circled or boxed, and I would definitely have a drawing of vertical angles. Because even though it makes sense right now, next Friday, you know how it is when you get to a test sometimes, all of a sudden your brain just goes blank and you forget everything that you learned. It's always nice to have little hints on your sheet to help you. All right, let's go ahead and prove this. This one's a difficult one to prove because I'm going to accept a lot of things for this next step. So once again, a proof starts with given information, and it has a statement that says, I want this at the end. So that means your proof should look like this starts off, and this should be our last step, which it is. That's how it's set up right now. All right. We first match up this first statement, and we see if it's our given statement. It is. So our first step, as most of the time it will be, is given. Yes. Yes, it's given. All right. Dos. That's 2. The second step says measure of angle 1 plus measure of angle 3 equals 180. And it also states that measure of angle 2 plus measure of angle 3 also equals 180. Let us look through our sheets, and I'm telling you right now, there's a bunch that work. There's some that are better than others. Well, let's go through ones that you think are good reasons. Yeah, did you have a reason?
Use theorem 2.
What's theorem 2?
Theorem 1.
What's theorem 1 say?
If two angles are from a linear pair, that those from have sum of 8 on the sheet. That is linear.
Yeah. So somehow said theorem 1 says if two angles form a linear pair, then those angles have a sum of 180. That is a good one to use. We just didn't talk about that theorem, so that'd be a good one on the test to use. We're just not going to use it right now. It's a postulate, but absolutely that's a great one. Like I said, I'm going to say almost these are going to be awesome answers. Yeah. Theorem 5, we cannot use, theorem 5? If two angles are each supplementary to congruent angles or the same angles, then they're congruent to each other. This actually builds up to that one, so it's not quite that one. Yep.
Definition of supplementary.
Definition of supplementary, I would accept that one. The only reason why it's not the strongest one is I didn't say they're supplementary.
Oh.
That'd be a very strong one if I put a step 2 here and say that those two things are supplementary.
Yeah.
And then I'd say, because of that. That's why it's a little weak. I would accept it, but it's a little weaker. Yeah.
Is the definition of linear pair?
Linear pair is a good way to go. Linear pair is a good way to go. And a little stronger than the definition of linear pair. Because let's all look at the definition of linear pair. So the definition of linear pair is two angles that are adjacent and form a line. It doesn't really tell me 180 degrees. But if you look at the linear pair postulate. Linear pair postulate says if two angles are a linear pair, then they are supplementary. And supplementary is 180. So that'd probably be a really strong one to use. And like I said, you heard me saying that most of these are good ones. I'm going to put 2 down here. I'm going to put 2 down. I'm going to put the linear pair postulate. That would be super strong. And I want to put a second one. Maybe I should put an R on there. And if you turn the page, it's slightly weaker, but it's still pretty strong, is the angle addition postulate, because I'm adding 2 angles together. And that's the one that lets me add 2 angles together to get the whole thing. So in here, you might want to use the angle addition postulate. But here's the cool thing about proofs. This one's set up for you, so it's hard to know what the writer was thinking when they wrote this. It's hard to think, what was Mr. Pabian thinking, what ones was he looking at? When you're writing your own proof, and we'll get used to it, it is like writing a paragraph, where each of our paragraphs are going to be different, but they all might be 100% correct. Even with one step, there's a lot of postulates and stuff I would accept. I would accept anything with supplementary, because that's what we're doing. I'm looking for anything that, do you understand what's happening in this step? If you'd put something like, I don't know, the addition property of equality, I probably wouldn't accept that. But as long as you're dealing with what I put up there, then you're going to be okay. All right, so one of those two, or we had lots of other good ones that I said okay, and you could leave those on there. All right. Our next step says, we went from here to here, and we're going to see a lot of that throughout this time. And my hint is, what's actually happening here is I'm taking that and replacing 180 with that bit of information. There are two reasons I would accept on this one. There might be more, but right off the top of my head, I'm thinking of two really good reasons for that. Yeah. The transitive postulate would be awesome because this equals to that, this equals to that, so that equals that. That is not the strongest one. There is one slightly stronger. You got it? Substitution property is the best answer for this one. Transitive, you still get full points. Substitution is the best because that's actually what I'm doing. I'm taking this and plugging it in. Transitive is usually A equals B, B equals C, so A equals C. So I'm going to use substitution as the strongest, but transitive, I would fully accept that. This is our substitution property of equality. If you don't know what the substitution property is, or if you don't know what the transitive property is, you need to look that stuff up. Or postulate, I should say. Make sure you're looking this stuff up as people say it. All right, last step. I went from here, and I got rid of the threes. How did I get rid of those threes? How did I get rid of those measure of angle threes? That's all you're asking yourself is, how did I do it? Because if you know how I did it, that generally tells you what the property was. Labib?
You subtracted both sides.
Uh-huh, and what would that be?
Subtraction property of equality.
Subtraction property of equality. I subtracted measure of angle 3 from both sides. Bing, bang, boom. We're done. And note that I said measure of angle 1 equals measure of angle 2. These mean the exact same thing. This is one of those rare cases that you could just end here and not even put that on there, and you still proved it. Okay? I like to put this in there because I always like ending with exactly what they wanted me to prove. But measure of angle 1 plus equaling measure of angle 2 is the same thing as they're congruent. Kind of question? Yeah?
Could you use the vertical angles theorem?
You could, except we're trying to prove it. We are proving the vertical angles theorem. And it's kind of like you can't use the word in the definition, so you can't say aardvark. The definition of aardvark is it's an aardvark. But now, after we prove it, we can use the vertical angles theorem anytime we want. We don't need to prove it again. We're done. Vertical angle theorem, solid. You can use it whenever you want to. All right, so from here on out, you can use the vertical angle theorem. Questions, comments, concerns on proofs, this proof? Make sure you're not just looking at this and going, I have no idea what just happened. Because we have a test next Friday, and this is our basis for proof writing. We're going to write proofs again in chapter 3, so now's the time to get that base solid so you know what's going on. Yeah?
Could you use like the addition property of equality?
Addition and subtraction, technically they're the same property because you're adding a negative to both sides. So if you put addition, property of equality, I give you full points. I'd be a little snarky saying, well, I didn't really add, I subtracted. But it's the same property. Because, right, you're adding a negative. Do you get what I'm saying? Maybe we're talking about different things. Are you sure I answered it? I feel like
Yeah, that's
You sure?
Yeah, it's fine. I get it.
If it was up to me, I probably wouldn't even have subtraction property of equality. I'd probably just have addition because it is adding a negative to both sides. Is that what you're talking about? Did I lose you?
I'm fine.
Okay. All right. Let's finish this off. All right. So let's find the values of x and y. So since these are vertical angles, and these guys are vertical angles, you just got to set up an equation where they're equal to. So if they're equal to the thing across, we can do something like 4x equals 6x minus 26. We just add 26 to both sides, which are going to be 4x plus 26 equals 6x. I would subtract 4x. Maybe I should write some of this down. I don't know how strong we are at algebra right now, which would give me 26 equals 2x. We would divide both sides by 2, and we come up with x equals 13. You work on the y's. I'll put up the answer up here. I'll put up the work. I'm just not going to talk through it. So I want you to solve the y's. I'll put it up here. I want to test your algebra skills or something.
What?
You're going to solve for y.
Oh. Yeah.
I don't want the answer.
How to
I want you to just have it written down.
written down.
Yep.
Got it.
So you're working on your own on this. Typically you don't, but you can, because you're not talking about, you're just talking about x value plugins. Generally, if you're doing x's. And if you ever have concerns, I don't take points off for not having degree symbols. Because it's just too much going on. Yeah, what's up? Yeah, go ahead. All right, it looks like everyone got 20, at least a couple of the few people I eyeballed. I generally just do kind of a poll of things. So let's go ahead and do this. I'm supposed to name 2 right triangles. Could someone name 1 right triangle that's up there? I just need 1. All right, yeah. Angle B? P, which angle P? Because I actually see 3 angle P's. I see QPL, I see LPM, and I see QPM. Which one? MPQ, perfect. I'm not trying to be a jerk, but if you just put P on the test, you actually lose points because you see how there's 3 of them? Generally, it's a safe bet to use 3 letters versus 1 letter. Leather.
LMP.
LMP, yeah. On that one, could you have used just angle M? Would I know what you're talking about?
Yeah.
But it's always good to name 3 letters. I'm just get in the habit of naming 3 letters, then you don't make a mistake by that. All right, name 2 adjacent complementary angles. So they need to be adjacent, and they need to be complementary. Can someone name 2 angles that are adjacent and also complementary? Yeah.
QPL.
And?
LPN.
Yeah, perfect. So QPL. And LPM. Do you all see those 2 angles? QPL is 40 degrees. LPM is 50. 50 plus 40 is 90 in my book. And they are also adjacent. Awesome. Awesome sauce. Okay, let's move down here. We are given angle AOB. And you see the little congruent symbol? That tells you you're not going to write a degree down. You're going to write what angle it's congruent to. So a congruent symbol with angles tells you your answer is going to also have an angle in it. An equal sign a lot of times will have a degree. All right. So this one says angle AOB is congruent to what angle is it congruent to? Do we know for 100% fact? Yeah. EOB. How do we know it's congruent to EOB? Because they're across from each other. They're vertical angles. AOB and EOD are directly across from each other. So they have the same exact measure. Do you have a question or do you have the next one?
Well, I was just saying that you wrote EOB.
Oh.
D, right?
Yep, I meant D. I said it, didn't I?
Yeah.
Did I say it right? I just wrote it wrong.
And I could answer it.
Okay. So the measure of angle AOB, I'll let people think about it for just a second. Think about what the measure of AOB is. What is the measure of AOB? Get it in your head. We got it. Write it down. All right, EJ.
80 degrees.
80 degrees. Did we all get 80 degrees? Yeah.
I knew it was gonna happen.
Do you have a backpack on the back of it? Oh.
I'm leaning back.
Oh, okay. That's a cool way to do it, though. Those chairs do not offer much catch in that regard. Once you're going, you're gone. It was very quiet, though. Like, I think if you didn't say anything, I don't know if I would have. It was like, because usually when people falling, it's like the giant boom. It was just like nice, and all of a sudden you're standing up.
I knew it was gonna happen.
Okay, EJ, can you tell us how you stay in your how did you get 180 degrees?
Well, angle AOF is 40 degrees.
Mm-hmm.
Angle BRC is 60 degrees. And well, angle FOC totals to 180 degrees.
Yep. Don't forget about that. Straight lines make 180 degrees.
So then you subtract 180 from
40 from,
Yeah.
yep.
Yeah.
So you have 180, you subtract 40, you subtract 60, and you are left with 80 degrees. Perfect. Love it. All right, angle COD is congruent to what angle? COD is congruent to what angle, Songha?
I got FOA.
You got FOA.
Right?
Oh. Let's look. All right, COD is right here, COD. And F, you said FOA? FOA, are those vertical angles? Do we agree?
Yes.
Awesome. Then let's stick with it. Yeah. All right, what is the measure of COD? What is the measure of COD, Zeiser?
Can I please use the bathroom?
Yeah. Do you have this answer?
Yes.
What is
I
it?
do. 40 degrees.
40 degrees because they're vertical angles, right?
Yes.
We have AOF and COD are vertical. All right. If I go too fast, make sure you slow me down if you're not sure what I'm talking about, because I just sometimes point to angles and hope you see them on your sheet. Please stop me if you're stuck, if you don't realize they're vertical angles. The worst thing you can do in this class is be confused all day, go home, be confused, study for the test, be confused, and surprise, surprise, you don't do well on the test. Surprise, surprise. All right, we have about 10 more minutes. We got plenty of time. Real quick. I'm going to play devil's advocate here. We have 80 degrees here. Let's pretend on this exact same problem. I gave you 80, 60, and I asked you to find COD. Can someone tell me a way to do it without even having that vertical angle? Yeah.
Figure out angle F.
Figure out angle F.
Oh,
What's angle
Not sure what angle F is.
FOA.
Oh, figure out FOA?
Yeah.
Yep, we could figure out FOA. What's a more direct way? Rather than finding another angle, we can go directly into this angle. Yeah.
You could find 80 plus 60 and then subtract that from 100.
Yes. Your way is perfect, but this way is a little quicker because don't forget any straight line's 180 degrees. Any straight line's 180. Don't forget about those tricks. We didn't need that because we already had the 40, and so this is 40 degrees. All right, we have FOB, FOB. What's the vertical angle to FOB? This is probably the hardest vertical angle that we've done so far. What's the vertical angle to FOB? Yeah. COE, perfect. Perfect. Angle COE. Here's what I do. Here's what I do in my head to save me a little heartache. CFOB, I'm going to look at the rays that make it up. We have ray BO. Ooh, stinky. And then we have this, that's the wrong thing. And then we have, wait, what am I doing? Yeah. And then we have this one here. I was just highlighting the wrong stuff. So FOB is vertical to EOC. Sometimes just highlighting that stuff can help you see when you have a whole bunch of different lines. All right, but that is 100% correct. What is the measure of angle CO? Echo. What is the measure of COE? Songha.
Angle FOB.
Angle FOB.
Right?
They are congruent,
But they're not crossing each other.
but I didn't ask for congruent.
Angle? Oh.
I have the equals. I should have an M here, actually. That is on my... Does yours have an M on it?
No.
No, yours should have an M on it. That would be the confusion. With the M on it, does that change your answer at all?
Let me think.
Could we call on someone else?
800. No. I'll call someone else.
Okay, Labib.
Oh, 120.
120. So you're 100% correct that it's congruent to FOB, and the measure of FOB is 120 because 40 plus 80 gives you 120. So you were on the right. I asked the question wrong. That's on me. All right, any questions on what we covered? All right, questions from the homework. I'm going to tell you right now, don't worry about the challenge question. Don't worry about the challenge question. We haven't even talked about triangles. It was just to get you thinking. Our next chapter will be triangles. Yeah. Davion. Or, yeah.
So, I was just wondering, you know, number 11, when we did the statement,
Mm-hmm.
it's supposed to show, like, when it doesn't matter if we show, like, our answer after every step or show, like, each step.
Like showing your work.
Yeah.
You don't have to show your work.
Oh.
So what I had in the answer key is perfect. It's just the 3 major steps. You can show your work. You can show your work. So correct me if I'm wrong at what you're asking. You're kind of asking, should I have in between kind of like plus x, plus x? So you don't have to show that. And if you do, don't number it. Number your start point and your end point. But you can show your work if you want to, if it helps. Because a lot of times you're doing it anyway, so why not show it and then... But the major steps you number. Did I answer it in a roundabout kind of way?
That was
Okay, awesome. Yeah.
If you're adding the x's, why do you say subtraction rather than?
You know what? That should be what?
Yeah, on the answer key it said addition.
On the answer key it does say addition?
No, it said subtraction.
It says subtraction.
Yeah, I should say addition. I should say addition. And I'll tell you right now, was there someone in this class that caught the error that the math was wrong too?
Did you do that yesterday?
This used to be a different problem, and sometimes when I change the problem, I change just part of my work, and I didn't change enough of it. I didn't have the right answer, and I didn't have all the rights. So it should say addition. Thank you for bringing that up. Then I can bring that up in the next class. Thank you so much for bringing that up. Other questions? Yeah.
I have a question at number 10.
Cool.
Step 2, their postulate.
That's what I put.
But I thought the answer was, could it also be, wait,
Nope, for step 2 I have linear pair postulate, and then I have definition of supplementary for the
yeah, I
last.
put- yeah, got it.
Woo, we both did it.
Number 12.
Number 12, don't worry about it. Don't worry about the challenge one. That was just to get you thinking. That was just to